Hello! In this video, I want to introduce you to 6 very notable features of the Quarkus-Arc extension. If you have already used Quarkus, you will certainly be using the Arc extension. Arc is Quarkus' own implementation of the CDI Lite specification, which in turn is part of the Eclipse Microprofile or Jakarta EE CDI specification. Arc supports CDI Lite in its entirety. Unlike in classic CDI implementations, there's only a single bean archive available, which consists of annotated beans from your own application and those from dependencies that meet certain requirements. In addition to the officially specified features, Arc offers a whole range of interesting features that are not part of the CDI specification. The complete list is linked. Please be aware that these features are Arc-specific and may get in your way if you plan to migrate your application from Quarkus to another microprofile implementation. Default beans. With Arc, you can declare beans in the CDI container as default beans. Default beans are only used for injection if there are no other candidates. Here, for example, you can see a REST resource that uses a greeting service to generate an HTTP response with a personalized greeting. The greeting service is described by an interface. To create an implementation that is used when no other implementation of greeting service is available, you use the default bean annotation, either together with the scope annotation or, as in my example here, with a producer method on a bean with a pseudoscope, such as dependent, for example. The default greeting service is now injected into the REST resource because no other CDI bean is defined elsewhere. Since default greeting service is now only a default implementation, you can easily create another implementation and define it as a CDI bean. This implementation will then be preferred over the default bean automatically. Default beans are therefore particularly suitable for developers of libraries or extensions who want to implement a specific standard behavior that does not require prior configuration or boilerplate code in its applications. Within applications, you can use them to define standard behavior that is only overridden for certain environments, for example. Removal of unused beans. In line with the Quarkus philosophy of moving as many tasks as possible from runtime to the build phase, Quarkus automatically removes CDI beans during build time so that they do not become part of the build application. Quarkus uses a configurable algorithm to detect unused CDI beans, which also excludes interceptors and decorators that cannot be used. In my example, Quarkus would remove this default config class and the default greeting service as well as default bean from the CDI container, as these beans do not have an injection point with the current implementation. When Quarkus is running in dev mode, you can view the removed beans, interceptors and decorators in the dev UI under Removed Components in the Arc extension. In addition to the 2 CDI beans I mentioned, there's a bunch of other beans that are not needed in my small application and have therefore been removed. This approach ultimately leads to a significantly reduced memory footprint compared to classic CDI environments and is unique to Quarkus. Enabling beans for Quarkus build profile. You can make a CDI bean to being only created when a certain build profile is active. For example, I could create a third implementation of a greeting service named prod greeting service, for example, which should only be picked up when building the application for productive use. To do this, you can mark the bean with the if build profile annotation along with a CDI scope annotation. The value of that annotation defines the name of the profile this bean is created for. Only if this profile is active during the build, it gets created and will be part of the application. Prod is a built-in profile used when no other profile is specified. My implementation would therefore not being picked up in dev mode. To negate this and activate a bean unless a certain profile is active, use the counterpart unless build profile. So when I run this, my greeting service implementation will still answer as the profile is dev when running in dev mode. But when I finally build the application via Maven, create the jar file and run this via the command line, Quarkus will use the prod profile for this. When I now repeat the request, the new productive service will answer as the implementation is registered only in prod profile and the other is not. Container-managed concurrency. Arc supports container-managed concurrency. Concurrency is nothing the CDI specification puts attention to. Arc, on the other side, comes with a built-in mechanism to avoid concurrent access on CDI beans. In my example, I introduce a simulated long-running I/O operation on the executing thread before answering with a personal greeting on calling the myGreeting service using thread.sleep with, let's say, 5 seconds. Starting 3 requests shows that the requests are executed in parallel, accessing the myGreeting service simultaneously. To avoid this, you would now use standard Java mechanisms such as defining the greeting method synchronized. Quarkus eases this by defining the log annotation, which can be placed on types and methods. Log on type level grants exclusive access for the caller on all methods on this bean. This is what write logs means. A read log, on the other hand, simply means that any number of clients can access the bean unless it is logged with a write log. Additionally, you can define a timeout for acquiring the log using the time and unit attributes. If the log cannot be acquired within this time, an exception is thrown by Arc. Without any configuration, log always grants exclusive access. All 3 invocations will be strictly executed sequentially. A timeout of 2 seconds would cancel an invocation after this time automatically, with an exception if another invocation is still running. Placing the log annotation on method level now allows for finer control per method with the very same semantics, but then only valid for this one method. This container built-in concurrency support is also unique to Quarkus and then sets it apart from other technologies. Injecting multiple bean instances. You might know this feature from the Spring framework. You have multiple injection candidates and want to inject them all as a list into another bean. This is perfectly doable with Arc. I shortly create a second greeting service as a CDI bean and adjust the greeting slightly. I now have 2 beans, both eligible for being injected into the greeting resource. You can now inject a list of all greeting services by changing the injection point to a list. The final greeting could now be the concatenation of the greetings from all services, for example. To tell Quarkus to inject all instances here, you have to place the all annotation at the injection point. Both implementations are now injected, ordered by their priority. And finally, intercepted self-invocation. When working with interceptors, you are usually familiar with the behavior that self-invoked methods on a CDI bean are not intercepted. For example, if I changed the implementation of this greeting service to create the greeting in a second inner method. This is a simple example, but let's assume this method should be transactional since it accessed data in the database. You would then add a transaction annotation on it, expecting that the runtime handles some transaction stuff for you. Since this method is not invoked from outside but self-invoked, you usually see no transaction here. In fact, the CDI specification is not clear about this should work or not. Anyway, when using Quarkus, self-invocations are always intercepted, so with Quarkus this will work. The only need is the method being invoked not being private, as it is in my case here. To demonstrate this, I have written a simple interceptor binding, simply printing the class and method name to the console on invoking a method annotated with my own logging annotation. The new method in my greeting service now got this annotation. A request reveals that the self-invoked method is private. Private is the only visibility which does not work with self-invoked interceptors, but luckily Quarkus complains loudly about this, not just silently skipping the interceptor. As soon as I change the visibility to package private, this works and you can see the message in the console. As I said, there are other exciting features of Arc. If you want to learn more about Quarkus, I can recommend you my Udemy course, which is linked below. So thank you for your interest and see you the next time.